This video will show you how to perform a two-independent sample t-test using SPSS. So as before, we're using our diet t-test data. The difference between an independent t-test and a paired t-test is, as the name suggests, when you have two pieces of independent data that you want to compare the means to. So for example, diet 1 versus diet 2, because we have completely different people in both of those groups. Whereas if we want to look at the start and end weight of diet 1, well, this value and this value, they're the same individual. So when you have two readings on the same person or the same sample, then that means the data have become paired. So that's when a paired t-test is important. And you can tell that also by the number of samples. For a paired t-test, they must be equal, but for an independent t-test, you don't have to have exactly the same number. It's better if the numbers can be as similar as possible, but it's not the end of the world if you have slightly more in group 1 than you do in group 2, for example. So in order to perform an independent t-test, you go to Analyze, Compare Means, Independent Samples t-test. In the test variable box, we want to put our dependent data. So in this case, this is our total weight loss. In our grouping variable, as the name suggests, we then tell SPSS how our groups are formed. And we do this by then clicking on Define Groups. In group 1, I look to see what the code is for diet 1, and it's 1. So I'll just enter 1. Group 2, or diet 2, is also the same, it's a 2. Now this could easily have been a 0, and this could easily have been a 1, and then I would be entering a 0 and a 1 here. It obviously makes more sense to have diet 1 called a 1 and diet 2 called 2, but these values can change, just so that you're aware. You then press Continue, OK, and then you end up with these two tables, and as with previous tests, you have a summary table. It tells you how many samples are in the analysis. You can see we're not quite even on the numbers. You can see what the average or the mean weight loss is for both diet 1 and diet 2, and then you have your standard deviations, your standard errors of that mean. In our table where we have our test statistic, we have an extra little test here called Levine's test for equality of variances. So another assumption of an independent sample t-test is that the variances are equal. So this is the test statistic for Levine's test, and this is the p-value. As with the normal distribution tests, it assumes equal variance until proven otherwise. So the fact that this is not significant means it's not significantly different from equal variance. The idea is that in that situation where the p-value is not significantly different, you can just read off the top row. If that had been less than 0.05 and was significantly different from equal variance, then you would read off the bottom row. For more thorough studies, if you're doing a postgrad, for example, you might want to question this because one of the assumptions of the t-test is the equality of variances. So some statisticians might argue that actually if it doesn't meet this criteria, you should think about a different test. But for most undergraduate purposes, this should be sufficient unless your lecturers have told you otherwise. In terms of the actual t-test, so we have here our test statistic, so we're reading off the top row because this was not significant, our degrees of freedom, and then we have our p-value. And as you can see, our p-value is a lot greater than 0.05, so that means it is not significantly different. There was no significant difference between the weight loss of diet 1 and diet 2. And that's not surprising because when we look at our mean, we have 3.3 kilograms and 3 kilograms. So I'm not surprised to see that those are not significantly different. So both of these are not that different from each other in terms of the weight loss. But the next question would be, were both of these diets actually effective? So when you look at the end weight compared to the beginning weight, and that's where your paired t-test would come in. So that's your summary of how to perform an independent sample t-test.